Good evening, students. Good evening. Am I audible? Voice clear? Thank you, beta. Thank you. Same to you. Okay, very good. So, last lecture we have discussed about which concept? We have started the resonance concept, right? Yesterday's class, it was the topic which is resonance. Have you revised the notes? Yesterday, have you revised the notes, class notes, and you have revised your own notes, earlier notes? NCERT page numbers I have given. Which page numbers given? 275, 276, and 109, 110. One is in chemical bonding, and one is in some basic principles of organic chemistry. Have you gone through it or not? Yes. Students are there. Tarani Pandey, Pushpa, Deepti, Bhavna, Srisha, Sai. Sandeep is not here today. Yesterday he was there. Pardu Rao, Srijal, very good. Gone through it. So main thing is that it is very important topic, and you have realized it that resonance is very fundamental. But when you solve it, it is difficult to write the structures. And it is useful for every chapter for organic chemistry. Every chapter we talk about the reaction wherever some delocalization takes place. It is which concept? Resonance concept. Okay? Yesterday we have discussed in resonance. In last class, we have discussed the which part? Definition we have done. Second, we have discussed its features or key points of resonance. Third, we have discussed about the conditions to show resonance. Conditions to show resonance and examples. So we have discussed up to this part. By this time we have discussed these three. These three parts we have discussed: definition, features of resonance, then conditions to show resonance effect, and examples. Examples may we have discussed which part? Only seeing the structure and find out where resonance is possible or not. That's it. We have not discussed about writing the multiple structures. Remember? Systematically we are going. So almost how many examples done yesterday? How many examples discussed? Almost 36, some are saying 33, okay, 35 also written, okay, fine. It is approximately 35 examples. Yesterday we have discussed. Now, today in this lecture we will discuss about rules to write resonating structures. Rules to write resonating structures. Clear? Start करें. Rules to write resonating structures. ठीक है चलो. First one. Position of atoms remains unchanged. Remains unchanged that is fixed, and position of pi bonds are changed, or pi electrons delocalize. What remains same? Position of atoms remains unchanged or same, and position of pi bonds will be changed, or pi electrons delocalized in different resonating structures of a molecule. ठीक है? So position of atom remains same, position of pi bonds will be changed, and when we write different structures of a same molecule. This point we keep in mind that while writing the structure, we do not touch any sigma bond network. Only what is touched, pi bond electrons are delocalized, or position of pi bonds will be changed. Second point, octet rule not violated for second period elements. Carbon, oxygen, nitrogen, fluorine. Octet rule not violated for which one? Second period elements like carbon, nitrogen, oxygen. Why we have to keep this in mind? Why octet rule should not be violated for them? Anyone? Why octet rule should not be violated for second period elements? Anyone? Answer not coming. Wake up. After the lunch, I think some of the students, so by this time they are taking a nap. Right time for nap, and that time class. Very good. Abhi given the answer. They consist only Abhi has said right deal not possible. Yes, very good. The reason is they do not have d orbitals available. They cannot expand their octet beyond 4 bonds or beyond 8 electrons. They cannot accept electrons because they do not contain d orbitals. They cannot expand. Yes, Srisha, right. Third, number of paired and unpaired electrons remains same. What remains same when we write different structures of a same molecule? The number of paired and unpaired electrons remains same. Overall charge remains conserved. Overall charge remains same. Overall charge remains same or remains conserved in each resonating structure of a molecule. These are the points. Generally, nobody asks the points, but learning the points is the key to solve the questions. You will implement these points in the examples. So that points are important to learn, understand, and then apply directly in the examples. Next point is similar charge. Similar charges on adjacent atoms or opposite charges on adjacent atoms are insignificant. Resonating structures or neglected structures. So while writing the structure, we do not write those structures where either similar charges are coming plus and plus closer, or we do not cleave the bond and put opposite charges adjacent. Writing the structure, we are not comparing right now. We are not comparing the stability. We are only writing the structure. So such structures will be not written where similar charge coming where on adjacent or opposite charge. Such structures we will not write. ठीक? We are discussing the rules to write the structures. Negative charge should be on more electronegative atom. Should be on more electronegative atom, and positive charge should be on less electronegative atom. Positive charge should be on less electronegative atom. So when we write the structure, we try to write or delocalize the pi electrons in such a manner. Negative charge should come on more electronegative atom and positive charge should come on less electronegative atom. Clear these points? Go through them again. These points we will keep in mind while writing the resonating structures. So go through these points once. Gone through it? Keep on writing these points. Wherever you have written extra points, add these points in your notes also. And if you want to share this with your friends, share with them. It's a good thing because all are preparing. The more you will be sharing with the friends, you will be getting better understanding of the concepts. You can discuss these examples also because it's a fundamental example for every chapter. Resonance. Gone through the points? Now, shall we start the examples? Writing the resonating structures. Bolo. Gone through these points, then I'll giving you more examples from the yesterday's lecture, that writing the resonating structures today. बोलो भाई जागो 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 नींद से जागो जाग गए चलो बहुत अच्छी बात है कम जागे लेकिन अभी भी स्टिल चले भाई Draw resonating structures. ठीक है, फर्स्ट एग्जाम्पल आई एम राइटिंग इट. फर्स्ट एग्जाम्पल, फर्स्टली वी विल चेक व्हाट इज रेजोनेंस पॉसिबल. तो ये लास्ट क्लास पार्ट यू कैन रिकॉल, इट्स अ टाइप ऑफ कॉन्जुगेट सिस्टम. यस, and it is pi sigma pi. Resonance is possible. If it is possible, then what we will do, delocalize the pi electrons. Here all are carbon, we can delocalize on any side, like this way also I can delocalize. Complete movement of electrons. Here an arrow is head, it is tail. Head means it is the movement of electrons here from left to right. Here movement of electrons, that is the meaning of complete arrow. So the structure will be, one such structure will be, firstly keep this fixed and only pi electrons will delocalize. Here plus and there minus. Electrons are moving here, this carbon become deficient. Here pi bond, this pi electron shifted on carbon, minus. Overall neutral, yes, overall neutral. Other, exactly we can write similar structure, CH2, CH single bond, CH, CH2. Here double bond, exactly we can write plus here and minus there. Yes, Sandeep, good evening. Yeah, you are late today. What happened? Slept? Okay, first example. First example, clear? Third bond there, we will see it. If it is a conjugate system, it can participate. If third bond is there, it's a conjugation, then we can delocalize. Till conjugate system is there, keep on delocalizing. Clear? Try next example. Okay, next one. It's a conjugate system, yes. Pi sigma pi, here any side we can delocalize. Only where conjugation is there, not on each carbon, because if sp3 carbon is there, there is no conjugation there, we do not write there any delocalization. So one such possible structure is here double bond, here plus and there minus. Pi electrons are moving away from here, plus. Pi electrons are going here, double bond, and here minus. Similarly, exactly structure we can write plus here and minus there. That you can, in the notebook you can write also, or the structure. Three structures are there. Total 3 structures. Completed. Third one. Pi sigma sigma, pi sigma sigma, no conjugation. Last class part we will use it, that if there is no conjugation, no resonance, no need to write any resonating structure. So last class concepts we are going to use today. Okay. Next one, pi sigma pi. Now in this example, observe, pi electrons will shift towards carbon or oxygen. Pi electrons towards carbon or oxygen. Yes. Towards more electronegative atom. Very good, Mallikarjun. So here, pi electrons will be towards oxygen. And simultaneously we can draw the structure. So here it will be CH2 single bond CH, single bond CH, carbon skeleton written. Here it will be minus, here it is double bond, here it is plus. Getting it? Pi electron delocalizing towards more electronegative atom. That will be a major resonating structure. Other structures, if given, we can say they are less contributing, less stable structures. Clear? Then hybrid also we can write for such structures. It will be partial dotted or partial bond will be there from here to there. Hybrid form, if you want to write, you can write for that depending upon the question. Here we are discussing about writing the resonating structures. We can also write their hybrid forms. Next one, pi sigma carbocation. Yesterday we have done pi sigma C plus, and C plus means always electron deficient, always carbocation. So here pi electrons will be where moving? From electron rich to electron deficient. Pi electrons moving from left to right. The structure will be here double bond, here plus. Getting it? If you want to write its hybrid form, it will be like this. Here it will be del positive and here also del positive. बोलो, आया समझ में? Delocalization we are discussing today on the basis of the points written. Pi sigma negative charge or lone pair, they always move away from the atom. Negative charge and lone pair always move away from the atom. So here conjugation, delocalize it away from the carbon. Moving this side, the structure will be here double bond, here minus charge. Seventh, pi sigma half filled orbital free radical. Now free radical mein we will use which arrow? Full arrow or half arrow? Full arrow means how many electrons? Rendu. And half arrow means okati electron. So here we will use half arrows because it is free radical. So structure will be yes, clear it is. Very good. Gopi and Naragni. Yes, it is half arrow. Very good. Up to 7th, any point, any questions you want to ask till 7th? till 7th. Till 7th, any questions? Up to 7th, any point? Yeah, fishing hook also, fish arrow also, half arrow, yes. Okay, next one. Pi sigma carbocation. Type of conjugation, yes, so it will be towards electron deficient. Pi electrons moving towards C plus carbocation, which is electron deficient. The structure will be like this. Want motivation. When you solve the questions, when you remember the theory part, internal motivation will be there. I will say something, it will be having temporary effect. But when you learn the things properly and you solve the questions on your own with maximum understanding, you yourself will feel good internally. That is the real motivation will come. Getting the point, Shushmita. Sometimes you will get, sometimes if you daily get this type of dose, that it will not work. Because main thing is always your hard work. Regular, consistent hard work is required. And that hard work means you are learning properly, you are attending the lectures properly. After the classes, you are going through the learning portion, recalling it 3 to 5 times. Okay, recalling 3 to 5 times, solving the examples once, revising other subject twice, thrice, 4, 5, like this. That keeps on going. No worries, beta. You have to work and your time will be there. Your time will come, maybe some loopholes in the preparation there. To let the people say, whoever blaming you, just remain silent. No need to any discuss with them anything. Just give your best this year. No need to think any negative. If you keep your mind busy with the negative points, then ultimately all this part which you are doing, you will not be able to focus. And right now, what is important for you? Leave everything, whatever mistakes done, focus fully on the learning portion. That yes, this year I'll get the selection. How? I work regularly without distractions. People are there, they will appreciate you also. They same people who are saying anything, blaming you, Sushmita, they will give you what? They will appreciate you also. You will guide them also later on. But till that point, have patience and work regularly. Silently work, and then when you are selected, that will be everywhere spread. Double bond position. Yes, yes. Double bond position here. I have written wrong. Here. Yes, thank you. या 8th में ये गलत कर दिया. ठीक है. 9th example. In 9th, can we write like this? No. Why? Because yesterday we have learned pi sigma sigma. It's not a conjugation. Hence, there is no resonating structure. Here, in this example, how many structures you can draw? How many structures you can draw for that? Pi electrons keep on delocalizing. Sigma bond network remains same. So how many structures total? How many structures are there for? It is which carbocation? It is primary benzyl carbocation. You might remember this one, primary benzyl carbocation. How many structures we can take? Is it 4 or 5? Let's see. How many resonating structures for 10th example? Very good. Those who are getting 5 are correct, and those who are getting 4, observe here. First structure and last one. Are they same or position of pi bond in the benzene ring different? It is different. So you will say how many structures resonating? 5 resonating structures of benzyl carbocation. And we can show its hybrid like this. If given in the options, you can write, you can mark that option. It is which one? It is the hybrid structure. Clear? Can I change the slide? Can I change the slide? ठीक है. Now write down the structure for similar for carbon ion. Try to write the structures. That is the basic thing of the resonance concept. You cannot learn the structure, practice these structures by writing with proper arrows. ठीक? Keep on writing it in rough notebook properly. In first one, negative sigma pi. Negative sigma pi is a conjugation. So pi electrons will delocalize from negative charge or lone pair, right? So here negative charge away from the atom. One such structure will be this one. Here minus, double bond CH2. Then we can write more structures also, similar like previous case, carbocation. Then also how many structures will be there? Then also there will be 5 resonating structures. Here multiple structures can be written. Ortho, para and again ortho. 5 structures, yes. I am not writing. You can write in your notebook after the class. Here, that way you can practice. You can write the examples in the notebook later also. ठीक है? Next one. In next one, resonance possible or not? Possible. Write down the structure. Pi, sigma, lone pair. Lone pair or negative charge. Move away from the atom. Yes. Therefore, delocalization. Sigma bond network same. It is double bond here plus and here minus. So observe here in these structures, we are not violating any rule of the resonating structure. Sigma bond network same, only what is changing? Location of pi bonds electrons are changing. ठीक, overall charge always same, it is overall neutral, it is overall neutral. Getting it? Octet rule not violated. Always number of paired and unpaired electrons remains same. If you count here 2, here participation of for 2 only, here it is 2 minus charge, and here pi bond 2. So that is always, when you say na structure, keep these points in mind. Similarly 13th, अरे भाई 13th में होगा कि नहीं होगा, ऐसे, and you will write the structure. NH2 will get with charge plus, and here minus. Why? N is neutral, it is donating the electron, it will be getting plus. Carbon is neutral, getting the electron minus. Overall neutral, overall plus minus neutral. आई बात समझ में? पक्का? Try remaining structures, properly write them. You can keep more space in your notes, in your practice notebook for 14th. You can write more structures after the class. Here at least write one structure. O should have negative charge. Here remember one thing, that is a general point, that when we delocalize the electron, the pi electrons will shift towards where? More electronegative atom. But here oxygen and carbon are singly bonded. Due to conjugation present, lone pairs will always move away from the atom. So such structures, yes, we can write where octet of oxygen is not, octet of oxygen is still complete. It is not deficient. It is not deficient, so O lone pair move away from the atom, whether it is oxygen or nitrogen. So lone pair or minus always move away from the atom. Okay, then one structure you can write for aniline. Bolo bhai, any point you want to ask up to these examples, up to 16th or 18th? But keep on trying it, do not leave, because we are doing very basic examples, 20, 30 examples. Practice them properly, it will be very useful for you. With charge on oxygen plus, here minus, and it will further delocalize. These structures are given in NCERT. In the different chapters you will get. Aniline important, phenol important, phenoxide important. Yes, here when you write the structures, it will be having how many structures? 5. Here also when you write 5. And when you write the hybrid form, O will get del positive and carbon will get del negative in hybrid form. Any questions? Here, now, C double bond O, sigma, pi. Right? Pi electrons will move towards more electronegative atom. And here it will be from the benzene towards outside, because carbon becomes deficient. So we can write this structure. Benzaldehyde in NCERT given that one. Yes, you will get in the aldehyde ketones chapter also, or in the resonance also we do. In hydrocarbons also we are going to use such concepts in directive influence. Electrophilic substitution reactions may we are using it. Bolo, up to 16th, till 16th. जागो भाई, जागो. Wake up. Lunch is digesting and you are sleeping. All correct. Very good, Sandeep. Anyone want to ask question up to 16th? If not, complete up to 20. 17th, possible? Yesterday we have done that example. Is it possible in 17th? Chaitu Reddy, very good. Yes. MSR, no. MSR, revise yesterday's notes. Seisha, yes, very good. Any other student? Think fast. Think fast. Sandeep saying, yes, very good. Tarini Pandey, yes, very good. Palaparthi, yes. Pushpa, yes, very good. Yesterday we have done that example. NCRT example it is. NO2 structure you will write like this in expanded form. N double bond O minus here plus. Yes, Alekhya, correct. Kareem Basha, correct. 12th one explains the octet rule. 12th में अरे यार कहाँ पे था ये लड़का, कहाँ चला गया? 12th में क्या दिक्कत आई भाई? Observe here. Oxygen and carbon. Lone pair sigma pi. Lone pair will move away from the atom. Here oxygen has octet still completed or not? Out of two lone pair, only one will participate at a time. Getting it, Akib? Always remember, if atom has two lone pair or three, only one will participate at a time in resonance. If a atom has pi bond and lone pair will not participate that time. So here, lone pairs 2, 1 will participate. Octet still complete and carbon octet also complete. कहानी आई समझ में? अब बात करेंगे हाँ ये वाला. Is it a conjugate system? Yes. Pi sigma negative. Negative will move away from the atom. ठीक. अब इसके बाद and here structure will be CH3 CH2 N O. Here it is minus, here double bond, here plus. And these two, 1 and 2, in NCRT they are given or not? CH3NO2. And 1 and 2 are which structures? Anyone remember? These are known as which structures? 1 and 2 are equivalent resonating structures or not? 1 and 2 are which structures? Equivalent resonating structures. You can observe here. Here double bond O, here single bond O minus. N remains plus. Here single bond O, here double bond O. Exactly say similar structure and pi electron density is moving only on oxygen. These are two equivalent resonating structures. So when you read the NCRT, you will get the NO bond length is same, which lies between single bond and double bond. 18th, possible? Complete up to 20, past. Then I'll write the structure. Till 20, write down the resonating structures. Completed? चलो 18 में नेगेटिव सिग्मा पाई CH3 C single bond here, sigma network same, and here are these two acetate ion, are these two equivalent resonating structures or not? These two. They are equivalent resonating structures. अरे जागो भाई जागो. Yes, very good. Yes, and the CO bond length is identical, and hybrid can be written like this. Here del minus, here del minus, or you can also write they are equivalent structures -1/2 and -1/2. Exactly equivalent structures means you can write down the -1/2 onto net charge is -1. ठीक है. 19th में possible. Lone pair sigma pi. Lone pair will move away from the atom. Structure will be CH3, C single bond O, CH3 here. Double bond here minus and here plus. 20th. अब एक बात बताओ, 20th में पॉसिबल है? हाँ जी पॉसिबल है, बिल्कुल पॉसिबल है. लोन पेयर सिग्मा पाई, लोन पेयर विल मूव अवे. लोन पेयर्स विल मूव अवे. क्या बनेगा? CH3. लोन पेयर्स विल मूव अवे, CH3 CO माइनस. ठीक है यार, ये O minus here double bond. Yes, Sandeep, correct. If equivalent structure, then we will say the bond length of CO is identical. Equivalent structure, then we can say NO bond length is same. Now tell me, in 20th acetic acid, is CO bond length is same or not? CO bond length in acetic acid is identical like acetate ion or different? Very good. Answer is coming. Other students also participate fast. Do not sleep. Lunch should not dominate. Chaitu Reddy, Sandeep is writing okay. Tarini, no, not same, different, not same. Very बढ़िया students हैं यार. Very good. Yes, CO bond length is not same in acetic acid. Why? They are non-equivalent structures. Very good, Naruto. They are non-equivalent structures. Why? It is neutral. Here formal charge present, non-equivalent structure. Above acetate ion, exactly identical. Only pi electron delocalize on one O minus, one double bond O. Second structure, one O minus, other double bond. Clear? So we can relate bond lengths also by using resonance. Up to 20 written or not? I will change the slide. Till 20. Till 20. ठीक है, very good. Keep on writing properly and keep on leaving the space wherever 5 structures are there. After the class, you have to complete it. ठीक? Write down the resonating structures. Write down the resonating structures. लिखते रहो. 21 में conjugation is there. Yes, pi sigma carbocation. Pi electrons will delocalize towards carbocation. One such structure is here double bond, here plus, here double bond. Second structure you can also draw. If you have space available, you can draw third structure also. It will be here, there. Clear? 21st. 3 resonating structures are there. If you want to draw hybrid, hybrid will be like this one. If asked, then we can mark in the options the hybrid structure also. Clear? 22. Pi sigma carbocation. Pi sigma carbocation sigma pi. Conjugation, delocalize. And here it will be double bond, here plus, like this. Clear? Or else you can delocalize here also, other structure also possible. लिख रहे हो? Write down the resonating structures properly with arrows. Do not copy it. Firstly, try from your end first. Then I'll write the answer so that you can check it. Now here, first structure. Here it will be double bond, here plus. Further possible or not? Negative will not come. In 22, there is no negative, it is carbocation. Plus, keep on delocalizing. We will not generate any further charge. We will only try to delocalize the electron. We will not break the bond into plus and minus further. Only delocalize it. Stability will increase. Then further structure is getting it. 23rd. It's a conjugation. You can directly write also lone pair sigma pi sigma carbocation. Lone pair will move away from the atom in this manner. आ रहा है समझ में पक्का? Getting how to write the resonating structures. That is the purpose of this lecture. Yesterday purpose was conditions, identify where resonance possible, and today class purpose is write down maximum type of resonating structures as per the NCERT coverage, as per the PYQ's coverage, all important examples. Take 24th. Here we can draw half arrows also, which is fishing hook like this, or you can directly write if you are comfortable with the structure, you can directly write this. Similarly, other structure also possible. Very good, Tarini Pandey, very good. Complete. Other students also. 25th, very important example. In NCERT given, twice. In hydrocarbon chapter given. And some basic organic principles also given, I think. Twice it is given. So here, pi electrons towards oxygen, more electronegative atom. And this will be shifted here. The structure will be here double bond N, here O minus, and here plus. Twenty-fourth hybrid you can draw if like this. If it is asked, we can draw hybrid in this manner in 24th. Here del free radical mention, here del free radical, here del free radical. Clear, Sandeep? 26th, possible? Twenty-sixth possible? Tell. Can I write like this? No. But inside the benzene ring, we can delocalize the pi electron density. And this is the structure. So here, resonance in the benzene possible, but not with the plus charge on nitrogen. Same example, last lecture we have done. That there is no resonance between the benzene with NH3 plus. Reason is the nitrogen is which hybridized? sp3 hybridized. Next one, acetyl chloride. Lone pair sigma pi. Lone pair will move away from the atom. Here it will be. Structure will be CH3, C here O minus, double bond Cl plus. Go Cl plus. Next one. Use proper arrows. If you are not practicing well, you will forget the point very easily. That's why keep on marking proper arrows from lone pair away from the atom in the conjugation. Up to 28th, anyone? Up to 28th, anyone want to ask? Okay, good. Complete it up to 30, then I'll change the slide. Done. ठीक है. Now in these two examples, we have tried the examples, delocalize the pi electrons. Whenever you have a doubt, do one thing. Do one thing where delocalize the electron and check is it violating any point of the rules. Here are the rules. Position of atom remains same. Octet rule should not be violated for second period elements. Overall charge remains same. So all these points. Akib, which example? Because wherever we are delocalizing the electrons wherever moving away, that atom will develop plus, which is getting the electron will get the minus. So it is movement of electrons, which is losing the electron will get plus, which is gaining the electron will get minus. So keep this in mind. I hope you will get the answer. So here what we will do, lone pair away from the atom. Try this way. If it is any violating any rule, we can say no, it's incorrect. If not violating, then we can say yes, it is a correct structure. Now, pi bonds, how many here? 3, O will get plus. Why? Oxygen has given lone pair. So which charge will come? Plus. And here carbon is getting it. Now tell me, is it violating any octet rule? No. Is overall charge remains same? Usha, Sandeep. 29th. No. Now tell, is it violating any resonating rule we have written? बोलो भाई, बोलो, जागो. Not violating, yes. So in 29th, delocalize the pi electrons and you are getting the structure, and here it will be not violating any rule, so it is resonating structure. That's why firstly solve the examples normally, and wherever some difficult examples are there, then specifically go through it, write the structure. Clear? So here C minus, no violation of octet rule, 8 electrons. Oxygen 3 bond 6 plus 2 8, no violation, hence it is correct resonating structure. Always when 2 electrons move, Akib, 2 electrons move, full arrow is written. In free radical only we use half arrow, which is fishing hook. Clear? Now, there is no sp3, sp2. In 30th, Aline's example. If you try here, best way is what? Whenever you have a doubt, do what? Try to delocalize electron and check is it violating any point of the rules written. Any side delocalize. Suppose you delocalize in this manner. Suppose I can write what? Suppose here sigma bond network written. If I write like this, here it is plus. Here already one pi bond, one more pi. Can you draw like this structure? Tell. Can you draw the structure like this? Best way is what? Whenever doubt, delocalize electron and check is it violating any points of the rules you have written. No. Reason, this carbon already 3 bond plus 2 bond, 5 bond. Is it possible? Is it possible to get 5 bonds with carbon? No. So they are not resonating structures. It will not show any resonance. आई बात समझ में? Getting it? Clear? So whenever you doubt, any doubt is there, what you will do? Delocalize the electron and check is it going against any rule. Here I am writing one more example for the sake of 30th only. Earlier even number, here odd. Try to do the same, delocalize electrons. Further delocalize electrons. Try to write the structure. If any violation, we will say no, it is not possible. So here, triple bond, here plus, here minus. Now tell, is it violating any rule? Chalo. 31 clear? Anyone? Anyone want to ask? 30th not possible, how? Write on the structure. 31 possible, write on the structure. No violation of any octet rule. C plus is not violation. Carbon has less than 8 possible, but more than 8 means violation of octet rule. Can I change the slide now? Can I change the slide? Bolo? Written or not? These all are the structures where delocalization is possible. How? We have written the points, how to delocalize the electrons by using the rules written. Bolo, bolo, jaldi bolo. Can I change the slide? अरे यार ये हाइड्रोजन सॉरी here hydrogen not there, right? Why? Tetravalent. Our student, yes Janvi, correct. Here it is H not there, already it is tetravalent without it. Where are lone pairs going? Lone pairs always move away from the atom in conjugation. Lone pairs always move away from the atom in conjugation. So here on in 23rd, if you go through it, oxygen lone pair sigma pi. Last lecture notes written na, condition conjugate system, lone pair sigma pi sigma carbocation, fully conjugated up to this part. So lone pairs will move away. So you can do what? Step by step you can do like here. Take double bond here plus. Then lone pair will delocalize with carbocation. Or you can directly write delocalization this structure. All are correct structures. Now clear? Can I change the slide? Bolo, bolo, jaldi bolo, bhai. Writing or not? No negative charge. अच्छा यार, negative charge का गड़बड़ है क्या? नहीं, so why negative charge will come? Why lone pair is delocalizing? Here double bond, O will get plus. Overall with charge positive, overall positive plus 1, overall positive. You've written the point, overall charge remains same in each resonating structure. So why negative charge will come? Nowhere. Positive is there. Electrons move here. Pi bond here plus. It is delocalizing here plus. ठीक है, after the class you can try these examples. When you revise it, you can write them randomly, you can pick those examples. Write down the resonating structures for 32. 33. 34. 'Finally, Akif got the answer. Which batch? Elite 2. LT batch, or it was, I think, seniors batch. Whenever you practice now properly and you get the answer on your own, remember one thing, you will always remember such concepts because you are working on your own, and when you get the answer, you feel very good. Internally you feel, yeah, yes, now I'm getting the concept. That feeling is required. If you simply copy it, if you take the Xerox directly, you're just reading it, there is no use, I'm telling you. But when you leave your laziness aside, you will say, yeah, I'll write everything, I'll work properly. Then your learning is taking place. Self-study is a very strong tool. If you simply take the notes, take the screenshot, thinking that I will do later, later effectiveness will never come. Later effectiveness is rarely for the student because they are trapped inside their own world. But once you are clear, I have to work systematically in a disciplined manner, writing each and everything, marking it properly, revising, recalling 10 times, 20 times, whatever. That will become your strength, and you will see with time, not suddenly. It will take 2 months, 3 months, whatever time. You will see the improvement is very strong and it will be consistent improvement. But you have to put the work. Sacrifice has to be done. Your mind will say, your heart will say, sleep, later do, go here and there. But your fundamentals are strong, they will say, nahi yaar, you have to stick to the work, complete it, then leave. Complete it, then leave. Fight from within required. And if you win from within, then you will win the world. If you are losing every time in your own world, and then nothing will be working outside. 32. Conjugation, yes. It will be here and here plus. Can we write one more structure? Possible? Yes, possible. How many structures are there? 3 resonating structures, and this example later we will use in which concept? This example later will be used where? In aromaticity. Later on we'll discuss about aromaticity, time is there. That time I'll take this example. Pi electrons, negative charge. Okay, where are you? Negative charge, move away from the atom, any side. Clear? Pi electrons here, further pi electrons there. One such structure. Double here, here minus. You can write more structures in your notebook later. This will be delocalizing, it will be delocalizing further. 33 example done. Thirty-fourth example. What's the name of this carbocation? 34th. You have done this already in the VSP sir lecture. Yes, I think carbocations, that time you got to know this. What's the name of 34th? 34th. Anilinium. Arey yaar, Mallikarjun, where have you attended the lectures? Troponium. Yes, troponium also, tropylium also. Both are correct. This is aromatic carbocation. If you remember that one. So here, resonance is possible. Yes, any side you can delocalize. There will be how many structures are there? 7 resonating structures. In the notebook, you can write after the class, tropylium. It has 7 resonating structures. "35th possible or not? 35th में possible. Samsung tab. Yeah, keep your names na, proper names also, so that I can say Samsung tab, rather that I will say yes, that one, that one. This is one of the more stable than this also there, but in syllabus we do not get these examples. More stable than tropylium also there, but tropylium is important for this syllabus. Yes, Gopi, it is aromatic. Now here, can I do like this? Bolo. In 35th, can I write like this? Somi Shetty saying very good. Kirtini, Triveni, tub shape. Nahi beta, Triveni not tub shape. Tub shape is different compound. Cot, cyclooctatetraene. It is not that one, it is 7-membered ring. 35th, is it correct written? Is it correct written? Wake up fast. 35th, is correct or not? 35th is correct or not? It is correct. Why? Is phosphorus is second period or third period? Octet rule should not be violated for second period. After that, third period contains d orbitals. Yes, hence we can expand their octet. So here it can delocalize, plus in the ring, ortho plus, delocalize, para plus, delocalize, ortho plus. If you write NH3 plus, that nitrogen will not participate. आई बात समझ में? पक्का? If yes, then try 36th carbonate NCERT example, chemical bonding. How many resonating structures of carbonate? Very good, Samsung tab. Next class, Samsung tab, change your name. Okay? Change your original, put your original name. You're studying here, you're a student. Why to write these names in class? How many structures will be there? 3 resonating structures. Correct it is. Getting it? Its hybrid also will be written like this. 3 equivalent resonating structures. So we can write directly -2 charge on how many oxygen? 3. So each oxygen you can write like -2/3, -2/3, and -2/3. Clear? This is which structure? This is hybrid, and these are resonating structures. Now 37th. Write down the all possible resonating structures. How many structures are there for 37th? Write down the structures. Before I write, complete your answer. Bolo. How many structures total? How many structures? How many structures? 37th. MSR, it will be informed, na? Some basic part will be there only. Students, are you there? Wake up. With 37 structure I have written, how many are there? How many resonating structures for 37th? Yes, there are total 7 resonating structures, not 5, Pavitra. Here I have written here, you can check, they are not same. Pi bonds of the benzene is different. So answer is how many for this structure? 7 resonating structures. Getting it? Try on your own after class. You can write in your notebook. Learn means conceptually learn that delocalization of pi electrons, all possibilities, maximum possibility. Then when you practice these examples, practice on your own. Later on, check the answer. Okay. 38th. Possible? Yes, lone pair will move away from the atom. It will become what? CH2 single bond, CH single bond, here NH2. When it delocalizes, here it will be double bond, here plus, here minus. You can message to Prasad ji na, Venkatesh. They will guide you regarding the NEET marks which you are saying addition or multiple. ठीक है ना, they will guide you. You can message in which group you are or whichever number you have. Prasad ji is there na, you can talk to them. They will guide you for any information related to that. 39th, possible lone pair sigma pi, lone pair or negative charge, move away from the atom. Moving means away means here double bond, here, and it becomes CH2. Sigma bond network same, fix it. Here double bond, plus will come, here minus. Next one. All correct. क्या बात है यार, very good, fantastic, excellent. If all are correct, then very good it is. Up to 40 done. Go through it. Any point up to 40? Except one, all correct. Very good यार, बहुत बढ़िया, fantastic. Up to 40 done. Can I change the slide? Can I change the slide? Write down all possible resonating structures. Complete these resonating structures. How many are there? 41. How many resonating structures will you write? Is free radical is delocalizing in the above ring or not? Tell. is free radical is delocalizing in the other ring or not? Kirtani, okay, very good. Yes, saying Kareem Basha, Ledu answer. Very good. Ramcharan, no. Tarini, no. Naruto, no. No, 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 no. Sisha saying yes. No. Answer is no. Because conjugation, observe here. Pi, sigma, free radical. When you delocalize the electron, it will be like this or not? Yes. So here it will be other structure. This is the structure or not? If radicals come here, then it will go under. So here, one given, second structure, third is what? Internally with benzene, pi electron delocalized. So answer will not be one, yeah. Total will be three. One this structure, other will be benzene, you can further write. Or here also, two possible, here two, total four. Sandeep, getting it? This structure, benzene, pi electron delocalized. Total two. This structure, total two. Total four. आया समझ में? Next one, possible. Students, write down the structure fast यार, क्या हो गया? Speed नहीं आ रही तुम लोगों की ना? Tired it seems. रेस तो अभी शुरू नहीं हुई है भाई. It's just warm up going on. Okay, complete it fast up to 47. Very good, Naruto. Very good, Kirtini. Very good. Complete it fast. 42. Yes or no? Is it possible like this? No. Is it possible like this? No. Why? Fluorine will not take the electrons beyond 8. So it is no resonance. But here possible. Why? Because Cl is having d orbitals available. So it becomes CH2 double bond Cl with minus. Getting it? So this is second period element. Which point is violated? Octet rule of fluorine will be violated. Here, Cl third period element, octet rule we do not check. Here, possible? Batao. But here, possible? Yes. So it is third period, it contains very good. It contains vacant orbitals. Good. Point is, you might have a doubt. There is nothing worry about that. Doubt is there. Work on the question on your own. You get the answer. Clear? Do not think here I am not getting. Read again. Read 10 times, 20 times, but do not give up. That attitude required. And then ask in the next class that I have doubt in this example. We'll discuss it. ठीक? Go through it. 46, 47, 48. हाफ सेंचुरी मारनी चाहिए यार आज लग रहा है मुझे. हाँ. Completed? Completed up to chalo. Kareem Basha saying, sir, enough. Okay, wait, beta, let's just complete. 51 ho jaye aaj. Last class 35 we have done that. Today 50 examples. After the class, you have too much work to revise it. है ना? 46 possible? Yes. Lone pair sigma carbocation. Type of conjugation? Yes. The structure will be CH2 double bond OH plus. Next one. Possible? Yes. Lone pair move away and delocalize in the conjugate system. अरे भाई आ रहा है, समझ में नहीं आ रहा. You are at home, yaar. Your mother will come and give you pakoda, punugu, and idli, and punugu, or khamman, or whatever it is, Mysore bhaji. All things are there at home. So why to worry? है ना? Next one. Lone pair Cl. CH2 double bond Cl plus. Resonance, yes. That is how you are finding out using the yesterday's theory. If it's a conjugate system, then pi electrons will delocalize. आ रहा है समझ में? पक्का? बस ये लास्ट एग्जांपल बचे. 49 पॉसिबल? But practice these examples with proper arrows. Your strength will be your arrows. If you are properly marking the arrows, then your understanding will be good. Similarly, it can participate. Resonance is there? Yes, resonance is possible. 50. 50 में can I delocalize here? बोलो. Yes, बस finishing line तक पहुंच गए हम लोग. Just you are running like this. 1, 2, 3. 50, 51. नहीं तो लोन पेयर नहीं करेंगे, पाई इलेक्ट्रॉन्स को एन पे डाल देंगे. क्या बनेगा? हेयर माइनस हेयर प्लस. We can write it, although stability is which one? First one, neutral. But if given, so we can write like this also. Here plus, here minus. Violation of no octet rule. Violation of no octet rule. बोलो, समझ में आया ये? पक्का? Last example. Possible? Yes. Lone pair sigma pi amide it is. Which degree amide? Which degree amide it is? Very good. It is secondary amide. Completed? Clear by these examples how to write resonating structures. All of you. How to write resonating structures. Yesterday we have done where resonance possible. Today we have done how to write resonating structures. If resonance is there, write down the delocalization of pi electrons. पक्का आया समझ में? हिम्मत तो नहीं हारी अभी तक? Still in the fight or not? Then you will be served with the hot tea, maybe herbal tea or maybe milk tea. And Kareem Basha is getting biryani today with some kebabs. Very good, Sandeep. Very good. Okay, students. So next class. What is the part? Tell me. Next part is what? Bolo, bolo. What's the next part? Tomorrow class. We have done features, definition, features, conditions, and where resonance possible, how to write resonating structures. Next part will be comparison of stability of different resonating structures. What's the next part tomorrow? Comparison of the or stability of the resonating structures. Very important concept. All are important about resonance. The topic is such a they are in ABC of these classes that it will be useful. If your friends are there, talk to them, tell them to join, or after class share your notes with them, help them. When you help other people, you will be also get helped. Okay? Okay, students. So tomorrow class is for comparison of the stability of different resonating structures. We will do so many examples tomorrow so that the complete resonance part will be clear. Okay? Thank you, Sandeep. Same to you. Thanks, Ahmed. Thanks, Akib, Alikya. Thank you very much. So tomorrow we will meet. Hopefully till that time you will be recharged. Complete that part 5 times. Revise that. These examples revise 5 times. Good examples you will mark them. Good examples. No, Naruto, never feel like this. Yeah, helping others means increasing competition. Never feel like this because you are just thinking directly what you are observing. There are a lot of things when you do good to others, now you will be helped indirectly, not for this part, in your lifetime also. So never be mean in these terms. If you discuss with the other students, your learning will be much better. You will remember the things much better. Okay, Naruto, so do not think about increasing competition. Right? Okay, students, take care. Bye-bye. Thanks a lot. Next class we'll meet. Take care. Bye.